Let's define an atom first. An atom is the smallest particle of an element that takes part in a chemical reaction. It has the same chemical properties as the element. So, an element basically, an element is a pure substance that cannot be broken down into simpler substances by chemical reactions. So, if we look at the element at a much smaller level into its particle level, those particles that collectively form an element are known as the atoms. Okay, so basically the smallest particle of an element that takes part in a chemical reaction and has the same chemical properties of that element. Okay, an atom, an element, basically, if we talk about the same element, let's take an example of sodium element. Okay, let's say sodium metal, this is an element. The same element is composed of the only one type of atoms, one type of atoms. Okay, so a sodium metal, a block of sodium metal will be composed of sodium atoms only. Chlorine gas in a jar will be composed of chlorine atoms only. Fluorine gas, fluorine atoms only, hydrogen gas, and so on. If we are talking about a single element will contain only one type of atoms. Okay, if we look into the at in if we look at the atom into a bit more detail, if we go inside the atom, we find subatomic particles. There are three types of subatomic particles: the protons, which are positively charged, neutrons, which are neutral, and electrons, which are negatively charged. Okay, this chart over here shows the relative masses and relative charges of each of the subatomic particle and their location. This chart is an important chart because it has been asked in both the theory paper and the MCQ paper. Okay, protons. The relative mass of proton is 1. Okay, let me clarify that these are just relative masses and relative charges. Okay, they are not the actual mass, or this is not the actual mass, nor is this the actual charge. Okay, relative mass meaning proton has a relative mass of 1. Neutron also has the same mass as the proton, so it has a value of 1 again. But electron is much lighter than either of the two, either of proton or neutron. So it has a relative mass of 1 over 1840. In some books, it's also referred to as 1 over 1836. It doesn't matter, both of them are acceptable. Okay, relative charge, protons are positively charged, so plus, and they have a charge of 1. Electron has the same charge as the proton, but with an opposite polarity and opposite sign. Protons have a charge of plus 1, electrons have a charge of minus 1. Neutrons are neutral, so they have no charge. They have a charge of 0. Location, both protons and neutrons are found inside the nucleus of an atom, but the electrons, they revolve around the nucleus in their respective orbits called shells. These shells are also called the principal quantum shells. Okay, I've given the values of the actual masses and the actual charges of protons, neutrons, and electrons. So let's take a look at these. Actual mass of proton is 1.67 exponent minus 27 kg. All of these are given in kgs. You don't need to learn these values because they are already given to you in the data booklet. Actual mass of proton is 1.67 exponent minus 27 kg. Mass of neutron is the same as the mass of proton, 1.67 exponent minus 27 kg. And mass of electron is 9.11 exponent minus 31 kg. The actual charge of proton is plus 1.6 exponent minus 19 coulombs, and the actual charge of an electron is minus 1.6 exponent minus 19 coulomb. There's the same magnitude as the charge of a proton, but with an opposite sign. Okay, if I take all the if I take a beam of the three subatomic particles, this as shown here by blue, this is a mixture of the three subatomic particles, and if I pass it perpendicularly in between two oppositely charged plates, so this beam over here in blue is contains protons, it contains neutrons, and it contains electrons. Protons are positive, electrons are negative, and neutrons are neutral. The protons being positively charged will be attracted towards the negative plate, and so once this beam passes in between the region in the region between the two plates, the protons will be attracted towards the negative plate and will be deflected upwards. The neutrons being neutral will not be attracted to either of the two plates, so will pass straight as is shown by the purple line, the straight line. Neutrons and the electrons being negatively charged will be attracted towards the positive plate, the lower plate, and hence will deflect downwards. Okay, one thing to notice here is that the angle of deflection of protons and electrons is not the same. The protons are deflected by a smaller angle compared to the angle by which the electrons are deflected. Reason is because the electrons are much lighter than the protons. They have the same charges, meaning the same magnitude of charge, so the same electrical force will be applied on both the charges. But since electrons have a much smaller mass, they'll be deflected greater by the same electrical force. So hence the angle of deflection through which the electrons are deflected, the angle through which the electrons are deflected will be greater than the angle of deflection of protons. Okay, now let's take a diagrammatic look to the atomic structure. Okay, this is our nucleus as shown by the purple. It contains protons and neutrons. The protons and neutrons are collectively known as nucleons. Around the nucleus there are electron shells which contain the electrons as shown by the red. Each shell is known as principal quantum shell as I told you guys earlier. They are also called energy levels. They may also be called shells, just shells. So different names of the same thing, okay? And they are represented by the symbol N. 99.99% mass approximately mass of an atom is concentrated within the nucleus. It contains both protons and neutrons and has an overall plus charge. The nucleus over here, this purple nucleus, has a charge of plus, has a positive charge because of the protons, the positively charged protons inside the nucleus, because the neutrons are neutral, so have no charge, but the protons being positive lead to the overall charge of the result in the overall charge of the nucleus being positive. An atom is always electrically neutral. Electrically neutral means the number of positive charges is equal to the number of negative charges. The positive charges are the protons which are found present inside the nucleus, and the negative charges are the electrons which revolve around the nucleus. So in an atom which is always neutral, the number of protons is gonna equal the number of electrons. Okay, now let's look at how to symbolize an atom of an element. This is the general symbolization of an atom ZXA. The Z over here as at the bottom, the subscript Z represents the atomic number. Atomic number is also called the proton number or the number of protons in the atom. This X represents the symbol of the atom, which is derived generally from the Latin name of the element. And A represents the nucleon number or the mass number, the sum of protons and neutrons. I've given an example down here. Okay, yeah, one more thing. In an atom, as I discussed earlier, it's electrically neutral. So this Z over here, the proton number, is gonna equal the number of electrons. So Z also is gonna equal the number of electrons because of the neutral nature of the atom. Atomic number is the number of protons plus the number of neutrons. Okay, let's look at an example. The sodium element. Sodium element has a Latin symbol Na. It has 11 protons and its nucleon number is 23. So 11 Na 23. This is how we are gonna symbolize the sodium atom. Magnesium, 12 protons Mg being its symbol, 24 being the nucleon number. Calcium, 20 being the proton number, Ca being the symbol, and 40 being the nucleon number. 19 being the proton number, K being the symbol, and 39 being the nucleon number. From the nucleon number and the proton number, when they are given, the number of neutrons can also be calculated by just subtracting the number of protons from the number of nucleons. 23 minus 11 will give us the number of neutrons present inside this element. It's sodium actually. Okay, so I guess that's it with the atomic structure. With the atom, I'll continue with ions in the next video, inshallah.